Hello viewers, today we'll learn about Apache Zookeeper. So let's get started. So what is Apache Zookeeper? What is the architecture? We'll see everything of it. Okay. So Zookeeper is a distributed application on its own while being on a coordination service for the distributed system. It has a simple client-server model in which clients are nodes, that is machines, and server are nodes. As a function, Zookeeper client makes use of the service and servers provide the services. Application make call to Zookeeper through a client library. The client library handles the interaction with the Zookeeper server here. Sessions are very important to the operation of Zookeeper. Requests in a session are executed in first out order. Once a client connects to a server, the session will be established and session ID is assigned to the client. The client sends heartbeats at a particular time interval to keep the session valid. If the Zookeeper assumes that it finds that it doesn't receive the heartbeat from the client for more than the session timeout period, then it resets that the client has died. Session timeout are usually represented in milliseconds. So a typical architecture of Zookeeper looks like this, where we can see we have multiple follower servers and one leader server, and clients can connect to any follower server, and all the follower server sync the data with the leader server. All the servers store a copy of the data in memory. A leader is elected at a startup. Follower service clients, all updates go through leader. Update responses are sent when a majority of servers have persisted the data. Now we can see that followers sync the data and leader also sync the data with the follower. All the CRUD operation which we perform is in sync with leaders and follower both. So Apache Zookeeper is an open source distributed coordination service that helps us to manage a large set of hosts. Management and coordination in a distributed environment is tricky. Zookeeper automates this process and allows the developer to focus on building software features rather than worry about its distributed nature. Zookeeper helps you to maintain configuration information, naming, group service for distributed application. It implements different protocol on the cluster so that the applications should not implement on their own. It provides a single coherent view of multiple machines. So why should we use Zookeeper? We should use Zookeeper for multiple benefits, which is, for example, it allows for mutual exclusion and cooperation between server processes. It ensures that your application runs consistently. The transaction process is never completed partially. It is either given the status of success or failure. The distributed state can be held up, but it's never wrong. Irrespective to the server that it connects to, a client will be able to see the same view of the service. Zookeeper helps you to encode the data as per the specific set of rules. It helps to maintain a standard hierarchical namespace similar to files and directories. Computers which runs as a single system which can be locally or geographically connected. It allows you to join or leave nodes in a cluster and node status at the real time. You can increase performance by deploying more machines. It allows you to elect a node as a leader for better coordination. Zookeeper works fast with workloads where reads to the data are more common than the writes. So a typical data model in Zookeeper looks like this. It is similar to the standard file system. The namespace provided by the Zookeeper is basically a sequence of path elements with separated by slash. So you can see it starts with the root node with the slash. Zookeeper namespace path identifies is different for each node. Moreover, in a Zookeeper namespace, each node can have data associated with it and its children, as same as the file system, which permits a file to also be a directory. The Zookeeper data model follows a hierarchical namespace where each node is called ZNode. A node is a system where the cluster runs. Every ZNode has data. It may or may not have children. ZNode path is canonical, slash separated, and absolute. It doesn't use any relative reference. Name may have Unicode characters as well. ZNode maintains static structure and version number for data exchanges. There are three types of ZNode: persistent, ephemeral, and sequential. So persistent ZNode is the type of ZNode which is alive even after the client which creates the specified ZNode is disconnected. By default in Zookeeper, all the nodes are persistent if it is not specified. Ephemeral ZNode. This type of Zookeeper ZNode are alive until the client is alive. Therefore, when the client gets disconnected from the Zookeeper, it will also be deleted. Moreover, ephemeral nodes are not allowed to have children. Sequential ZNode. Sequential ZNode can be either ephemeral or persistent. So when a new ZNode is created as a sequential ZNode, you can assign the path of the ZNode by attaching a 10-digit sequence number to the original. So what are the different applications with Apache Zookeeper? So Apache Zookeeper helps for following purposes: for managing the configuration, naming services, choosing the leaders, queuing the messages, managing the notification system, synchronization, and distributed cluster management. Now with pros, there comes the cons as well. So what are the disadvantages of using Zookeeper? So you may experience some data loss if you are adding new Zookeeper service. No migration is allowed for users. It doesn't offer support for rack placement and awareness. Zookeeper does not allow you to reduce the number of pods to prevent accidental data loss. You cannot switch service to host networking without a full reinstallation when the service is deployed on a virtual network. Service does not support changing volume requirements once the initial deployment is over. There are a large number of nodes involved, so there could be more than one point of failure. And at last, message can be lost in the communication with the communication network. So what are the highlights of Zookeeper? Zookeeper architecture goes through the master node, so all the writes are guaranteed to be sequential. When performing a write operation to Zookeeper, each server connected to this client stores data along with the master server. This keeps all the server updated with the data. However, this also means that concurrent writes cannot be performed. Apache Zookeeper might be a data model. Each directory in our example is called a ZNode in Zookeeper. It stores statistical data such as version details and user data up to 1 MB in size. If the master node fails, another master node is instantly selected and takes over from the previous master node. In addition to the master and slave, there are also observers in Zookeeper. Multiple server nodes are collectively called Zookeeper nodes. Zookeeper architecture clients uses at least one server at a given time. So in a typical architecture, you will see multiple clients can connect to multiple Zookeeper servers, and all the follower server sync the data with the Zookeeper server leader. So that's all for today, and if you think the videos are helpful, do like the video and subscribe to the channel.